Hi, my name's Tom Brady. I'm going to be doing, let's see, the first one is a ZDB file layout. So with RAID Z and DRAID and other things, your file blocks, unlike a traditional file system where they're just kind of all written sequentially on the disk, they're going to be spread out across, in the RAID Z example, different columns. And there's parity involved, and while you're doing an allocation, metadata will jump in there and whatnot. So I was looking for a way to do this. It's still a work in progress, especially for the DRAID stuff. But for the RAID Z, I can show you. I have let's see. I got a RAID Z full with 8 disks. This was expanded. I wanted to show the layout different across a RAID Z expansion, but somehow I didn't write the data right, so I ended up overwriting the original data. So I don't have that example, but I'll go ahead and run. So what this is going to do, you do a -F, you specify a data set and an object, and it'll show you how that one particular file was laid out on disk. So I'm going to scroll it back. Yeah, so you can see in this case, we started the parity on disk 4. Then the data just went around. Someone allocated something, and then we ended up on disk 2, came back around. These are all the different blocks for the file. I think it's 128K blocks. So you can see that in that first parity one, it's taking 43 sectors, starting at sector offset B05, A00. And so I think it's a useful tool to kind of see how things are going. Ideally, your parity is distributed across all the disks, so you can use the bandwidth of all the disks. But in some pathological cases, you just end up with, and this particular file, I left compression off so you could see kind of uniform. When you have compression on, you get smaller pieces and whatnot. So that's the demo. Any questions or? I'm working on the DRAID part, but right now it works, and it's broken for RAID Z1 because every 1 meg RAID Z1 swizzles 2 of the parity in the first disk, and so my code assumed like the disks were always incrementing in size. So I'll fix that, but yeah, mostly I've been testing with RAID Z2 and RAID Z3. So, question? I think it would, but if you had disparate VDEVs, like if you had one that had more disk, obviously this is like hard coding the comments. Actually, it might. I mean, I'll have to try that. I had something sort of working, but yeah. And then the other idea I had was like doing what is SVG, some type of format where you can actually visualize it graphically. But this is a good start, I think.
What was the original motivation?
Just trying to figure out how your thing ended up on the disk, basically. So.
I mostly see all this from perspective of C fragmentation, usual way through the list of blocks where file reside, but I wonder if it's more.
Okay. Then my I got to make that one bigger too. Okay, my next one is, I talked about Z-test yesterday, and was thinking about, I didn't show yesterday, but you can actually have, in Z-test, you can have a mirror of like RAID Zs, 2 RAID Zs. And that's great because you're, everything all at once, you're testing both mirrors and RAID Z. And so I thought, well, let's take it to the next level and let's test all the RAID Zs at the same time. So I have a triple mirror of RAID Z1, RAID Z2, and RAID Z3. And it's a little tricky to run because it's going to run for a bit, but I'll stop it when it hits, it'll run ZDB with the -s, yeah, so there it is. So that's the full config. It's a mirror of 3 different RAID Zs, and as you can see, when I run it, it's actually running all the tests and exercising all 3 of them at the same time. It's kind of a crazy idea, but I thought, why not take it to the next level? I tried to do a 4-way mirror with DRAID, but DRAID has these weird alignment constraints, and so with the mirror, it was like, right now it won't do, when you run Z-test, when it does DRAID, it won't mirror it like it does for all the other RAID Zs, but it's just like a kind of a bug or something that we need to chase down. But
trying to even understand how mirror of RAID would work. They are not identical, they have different alignments.
Well, the mirror is just going to write to the layer below it and just say, I need you to write here, and then whatever layer below is going to do what it needs to do to write that. So RAID Z1 will do something different than the RAID Z2, but at the end of the day, when they're asked for that block, they'll give it back. Other questions?
What does BOSS stand for?
Boss level in a video game is like the highest level. Like that's where everything's getting crazy. So
Okay, cool.
Makes sense.
That alone is good.
All right.
Cool.
All right, I worked on default user quotas. So the motivation here is, or the idea here is, if you don't know how many users you're going to have, and you want to make sure that any future users are limited on space, you could set a default user quota so that you don't need to set it in advance of them starting to use the file system, and still have a quota apply per user. So I'm going to create a zpool here. And you can see that my root user has no quota. I will set a default user quota of 1 megabyte. So you can see it there. I'll write a megabyte, write another megabyte, and I will have exceeded my quota. So even though I don't have a quota, my default user quota applied here. And if I say increase it, so my root user now has a 16 megabyte quota. You see here, so now I can try to write that file again, and this time it will work. I can add another user, this future user. I guess I already had a user 1. My future user that I didn't know about is going to write some file. Great, and then I'll try to write another one, and they will not be allowed because there's a default quota that they exceeded.
Where's that default configured?
That's it's a dataset property, so it's a new dataset property. Any questions? All right.
So what I worked on for this hackathon was kind of making some attempted improvements to ZFS tests based on some of the stuff that Don has brought up and things that we were talking about yesterday from after his talk. And so a few of those things are really just trying to, what in my mind, improve the reproducibility of Z-test, because right now you run it, it's just a random thing of operations. If you run it again, it's kind of difficult to try to generate the same actions that kind of resulted in whatever regression or test failed. So in my mind, if you can improve the reproducibility of it, you can, with a higher probability, hit the edge condition that resulted in the regression perhaps, and save some time while digging into your thing and not getting lucky on z-test. So what I tried to do was, there was a few things that I made in here. So the first change I made was inside z-test, there's some parameters that you don't have any control over in terms of when you want to run it again, and those were some of the SPA features such as fast dedupe and the space log map. So what I did was I moved those out to arguments that you can pass in via to the z-test command, and now they're not being randomly chosen every single time out of your control whenever you have no control over these ones when you do the test. So move those out. And the next thing is trying to, in each thread, like if you, all of the actions that are run inside, is it z-test run? Or is it z-test main? Oh, it's z-test thread. No. I don't know what that one is. Anyway, all of the actions that get chosen, like in terms of when it's trying to choose like a random function or test to run, it's choosing a random number, and in each thread, running it. So it would be great. We talked about this last time. If like you could pass in some sort of seed to the z-test function that would kind of like reproducibility in like a pseudo random kind of way, regenerate that. That same order of operations, because it would hopefully generate the same order if you use the same seed. So I added some functionality to z-test or get if z-pool or z-loop to pass in a seed, also another argument down here that would now get added on to whenever z-test gets called, and I also added some little things where it was like, oh, you can actually regenerate the same, like if you pass in a seed into z-test, regenerate the same arguments rather than copying and pasting it. So for example, if I were to do scripts zloop.sh, this was the seed that got passed in to z-test. It's not really used right now. I tried to reproduce some things, but z-test was way more complicated than I could have imagined. So it's hard to prove that it's doing anything. But it's getting passed in. And if I were to run zloop-sh or -s with the same seed again, it'll generate the same like arguments and all of these things and kind of like give you what you wanted to test again, and you can rerun it, and that's kind of what I did.
Question?
Yeah, I have a question. Yeah, okay, got it. You kind of answered it.
So instead of doing the salt, can you go ahead and just give it the straight commands that I want D3, S4, R3 versus instead of abstracting that away in the salt?
Yeah, totally. I mean, I feel like if I were on if I was running the CI that I just pulled a command, I think what most people do is they just will copy paste this and run it again. So this isn't that valuable, or this isn't that valuable. I thought it'd be fun to add.
Belt and suspended.
Yeah. Yeah. It's really, yeah.
Tell Jan to go ahead.
Go ahead, Jan. Oh, that was louder than I thought.
Would it make sense to re-architect the code gateway into a seed, which will get turned into the testing plan as a series of commands, what to do when, and then a runtime to execute that plan. So that you will have maybe a seed would emit an endless stream of auto tests. Could be CFS command line to execute them, and sleep delivery or something, you turn that into and the runtime could be a shell, so that you could just output the plan first for whatever runtime you pick, and then drive the test. So that maybe once you have a plan, I recognize it very deterministic as to what you're doing, even if it's not how you're doing it. You change it. Does that make sense? Can you estimate how much work that would be if it makes sense?
Yeah, I chose up this project because I was really unfamiliar with Z-tests. I've never used Z-tests, and it's kind of like a lot of digging into it. But when I was kind of like trying to use like a seed to try and like generate a plan, like you said, that would be reproducible, it seemed very difficult, and it would kind of require that re-architecture. I don't know if Don could speak to how much work that would be. I have no idea.
That would be a substantial amount of work, because right now zloop is just a script that's like you just run it to drive Z-test, but you could change it to be a plan-based, more comprehensive, more predictable driver of Z-test.
Yeah. And I feel like the plan could even be generated by Z-test via the seed, if you will. It doesn't need to be. Z-loop can still be a stupid runner.
Yeah, the goal was.
Oh, sorry, I was going to say, one thing I've been thinking about getting around to, but haven't done yet, was have ZKs as it runs, like output a log of the actions that it took in the order that they took them, and then that output could then be an input to the next run. So like, don't randomize this, actually run it. Because then you get a chance to replay the thing. But I really decided I loved it because it had to run for like, an hour and a half before it finally got there. To the thing that made it crash, like, I don't want to have to wait an hour and a half to see if the bug fix worked. So I hadn't quite thought about it. But I like to see if it could reproduce it. That's cool.
Yeah.
Wouldn't this also be very valuable because you could try to reduce the reproducer? If you had the plan which crashed and you can just remove the first half if it still crashes?
Yeah, maybe. So this is good. This is like the opening move on some really interesting ideas. I'm glad you did this.
Yeah, I wish I could have made more progress. I wasn't really familiar with Z-test, so it was a lot of reading today.
For sure. No, nice one.
Hi. So my hackathon project was I was trying to implement a interactive form of zpool create for ZFS, and I was trying to do it in Rust because Rust is neat. This was prompted partially by Alan's talk yesterday, and we were talking about how to give better user experience for users who have potentially many different kinds of VDEVs. And I thought that an interactive zpool create experience might be better, and it lets you do some fun things that I can talk about a little bit more. There's this new utility, zcreate. You provide a pool name for the pool you want to create. For now, it's printing a lot of debug information. There's a variety of flags that I didn't pass. And then there's this config file that stores information about different kinds of VDEVs. And so you can use this to store, hard drives have these tuning properties, NVMEs have these tuning properties. And so you can see here, we have NVMe drives with, a queue depth of 100,000. Whereas down here, we have spinning Rust. The description is spinning Rust, and the speed is very slow. And then the queue depth is -1. Just picking some numbers at random. And then so once it's loaded all of that information, it drops you into this REPL. And this lets you interactively choose how you want to modify your pool. Right now, we're at the top level. So you can see this is sort of the simplest possible pool configuration. It doesn't have any actual leaf disks yet, but you can see that there's the test pool. and it has like a stripe as its top level VDEV, because all pools start with the top level VDEV. And then we can navigate in using the REPL. And so now if we look, we are modifying the sort of top level stripe device. And from here, you can, create underlying VDEVs, print the whole configuration again, finish editing, or like edit the VDEVs, edit the child VDEVs, and all that kind of stuff. I won't go much further because if I do, it will crash horribly because nothing is implemented yet. But most of today was spent like getting the REPL working and getting sort of the architecture to make it easier to expand the rest of it. And then once all of this part of it is working, the next step is to actually get it to create an NV list that we could just give to zpool create and then let the rest of ZFS take care of it. So that's the demo and that's the thing. Any questions? I can also repeat.
Could this be modified to allow to see a current configuration of a pool?
So you mean like adding and removing devices on a pool that already exists?
Yeah.
I mean, in theory, the same architecture could be used. I did not plan for that, but like the same REPL infrastructure and the same sort of ZFS bindings and everything could theoretically be used for something like that. Yeah. The idea would be like you get the config from the kernel, it turns it into this tree structure, and then you could modify it, and we need to calculate like a list of diff operations or something, which would be an extra pass that has to happen. But in theory, yeah, we could do something like that.
Okay, thank you.
One of the other things that we talked about earlier in the conference at some point was setting VDEV properties as part of creating the pool. Did you look at that at all?
I did look at it. This does not implement it by any means, but it should be possible to either with the existing NVList interface or with some small modifications to it, where like we just add a properties field to each VDEV, and then get those things set on creation when we do pool creation. So it should definitely be possible.
Great.
Yeah, Jan, go ahead.
If you're supposed to do some kind of hand-holding for the user, so to really discourage them if they try to, let's say, create a 45-disk RAID Z1 VDEV?
I mean, we certainly could have warning messages, right? That would be easy enough. When it's considering the final configuration, it could say something like, warning, you have go ahead.
Or if you try to add a single disk to a redundant VDEV to a redundant pool.
Mm-hmm. Yeah. I mean, we could have reasonably intelligent stuff underneath that, would analyze based on the reported properties of the disk or like the properties in the configuration file. Like one of the configuration options, like if the backing is like an EBS volume, that's pretty reliable. You probably don't necessarily want to mirror that. Like you already have a bunch of nines of reliability. We could have like, you could specify like a minimum durability level or something where like the minimum amount of safety you would be willing to accept on your pool config. And it could warn you if you didn't have that just by doing like a pass over the tree at the end.
Please print type as follows YOLO.
Yeah.
You want to ignore the warning.
Yeah. There would definitely be a like, no, really, I know what I'm doing mode. Anything else you had? All right, cool. Thanks.
So I revived a project I started a while ago to try to solve one of the biggest problems people tend to run into when using ZFS replication, which is when you're receiving streams from other machines to your backup box and you want to keep the original incoming properties, you usually have to do something with the mount point. Otherwise, /var from your laptop overwrites /var or overmounts /var on your backup server or something like that. So I really wanted something like the alt root property that the pool has, where it prefixes every mount point with a static thing, but be able to control that for my /backups data set, so that each machine would have a mount prefix under that, and so each data set it receives would get its original path but prefixed with this kind of alt root thing in front of it. And so I've built the mount prefix property that allows you to basically force a string on the front of a mount point. So even if your mount point is absolute as, /var, it will get the prefix put in front of it, and you can have different prefixes per machine that you're backing up or whatever, and it inherits and goes all the way down. And it's almost working. The biggest problem right now is deciding what inheritance means in that case. If you have an alt root on a grandparent, and then you have a mount prefix on a grandparent and a different mount prefix on a child, should they be additive or should it replace the mount root? The mount prefix. And then from there, I will finish building it and make a pull request. And then yes, Mav brings up a really good point of if you're pulling it from another machine, what do you want the mount prefix property to do when you receive it? You want the local one to win instead, right? And so what kind of specialness do we have to do so that mount prefix is not pulled in over replication, because then it will possibly lead to a really long mount prefix. Or ideas on how to solve the problems that we just figured out. Okay, thank you. Okay.
Recommendation would be just making a regex and use search and replace on the at receive time, so that you can do arbitrary stupid things. And the other one would be that you exclude it on receive. On the receive side, you would exclude that property.
Yeah, I'm thinking possibly that just, like Mav's idea of just ignore it when you're receiving and apply the local. Yeah, or -x, I guess, to exclude it when you're receiving.
You can filter, just ignore it from the stream.
Yeah.
Don't receive it.
But it feels a little bit like you maybe should ignore that one automatically, but that's not normal thing to do either, and it's kind of surprising to the user that there's one property that we magically ignore, so I don't know what the right thing to do is.
But you need to maintain it. You still need to maintain it if it goes back.
Yeah, if you ship it and bring it back, you'd like it to not disappear. So, yeah, I guess just extra documentation that, you might, if you don't trust the other side, you might want to exclude their mount prefix. If they're additive, it can't hurt you because your mount prefix is going in front of their mount prefix. But if it replaces, then they could have a mount prefix of / or something. Yeah. That's harder to implement, though.
I'm sorry.
But it does seem to be the right thing to do. Yeah. We have to protect them from themselves. Okay.
So it's just small, short, not too much to present, but honestly yours got punished by commit bit, and with Brian we discussed how can we improve processes and to reduce number of tickets that make it more easily to manage. So we're investigating that possibilities of GitHub related to putting tags or labels, removing them, and other functionality of possible workflows through the GitHub issues and PRs to make it faster and cleaner, easier to manage for people. So you already could see a few merges. Hopefully, I help to improve the processes for people.
Yeah, you got some of that. Yeah, I should do that. Yeah.
Plus, I wandered around and we had some various conversations about how to get more people maybe involved in the review process, to get more feedback on things. Some of the ideas kicked around were maintaining a file in the tree for reviewers, particular subsystems or areas where they're willing to provide feedback. But yeah, anything we can do to improve the workflow of PRs and make it a little more visible about how to move things forward or what the next steps are there. So if people have more thoughts about that or things we could do to improve there, let us know.
Thank you.
Well, and while you're up there, we got Alan and a special class tutoring.
I have a plan to work. Actually, let's start from different side. There was for probably several years now a demand to specify different behaviors for different kinds of special VDEVs. Right now we have at least several. We counted maybe about 5 of different special kinds of how special is special kind of VDEV. We have metadata. We have dedupe/BRT. We have small blocks. We have potentially secondary streams of files, which can be extended attributes. And in different situations, you may wish different placement for those things. Because, for example, if you use derate, pretty wide, you want small blocks to be definitely on your special VDEVs. In some other cases, you may not want to have that. In some cases, you may have your ZIL to be put on special VDEVs, because again, writing ZIL onto main derate probably won't end up very good and efficient with total sync through all the devices. I think Rob Norris working on improving that side, but at least it's not yet. But even if it's improved, it's still maybe not perfect. So our idea at this point is to introduce probably a new type of property, which would be a bit field of several things. And we're gonna introduce VDEV level property that you would be able to specify which exactly kind of things you consider to be special for this particular VDEV. So I think we could have a default. So if you just specify special, it would mean some sort of default, but you can go and manually modify what exactly do you want to be special. That's one side of the project. As another side of the project, I have a plan for probably next year or about. I gradually get to that. I need to prepare some things in advance to introduce some sort of storage tiering to ZFS. And as part of that, we need to store actually, to be able to have different kind of VDEVs for different tiers. And we could use the same property, not only for special VDEVs, but also for any VDEV practically. In that case, special VDEV would appear just a VDEV with that property set to whatever to some default. But you can go to any VDEV and say, okay, this is tier 1, this is tier 2, tier 3. And as next step of a project, we could introduce additional attributes among the system attributes, which would specify what kind of tier this particular file belongs to. So you could modify a tier for a file, trigger its rewrite. That's another part of a project I'm going to approach it before I'll get to the point of tiers. And you can modify your tier level, rewrite the file. It will be read from one tier or written to another tier, and call it a day. So no, that's out of question of ZFS. It will be some other functionality.
So you could use that feature as that.
Yes. So something outside could look on any property like file size, last access time, modification time, whatever you want to script. That would set that tier level and then trigger a rewrite of the file. We could decide how exactly do that. We were thinking about different options like recompressing process. Do you want or not? We could do that. Change other things while doing that potentially.
There's a question from Jan.
Jan, do you have a question?
To move files between tiers without block pointer rewriting, but similar to copy file range?
The process for redirting the file.
Yeah, we had that question. I brought it up. We don't have exact good question. What should that syscall be? It's not exactly a copy file range. Maybe we could call it into itself a special case. But that would be... Well, potentially, yeah, you could create a new file with different block size, copy this file to that file, but my wish was to do it within existing files so that you could do it under the load. Previously, we discussed that previously during
device
during device removal, we had functionality of rewriting a file, but since it was done below ZFS file system layer, it could not get proper range locks. That's why it was unsafe. But if the sync would be done per file and go through the VFS layer, then it could take proper range locks. It could, under the load, rewrite the file and make it transparent and safe. And so, yeah, that's what. And that actually, using copy file range maybe not a bad idea. Just, I don't know what's the copy file range. It should allow within this file itself. Yeah, I don't know what we'll think about.
I think it has to be non-overlapping, though.
Yeah.
And right now it'll BRT, which is not what we wanted to do.
Well, it's unspecified, I think, what happens if you have an exact match. There's the copy file range. You would set the new tier and then say copy file range with the same file descriptor and range.
No, yeah,
So
VFS layer of
perfectly overlapping.
VFS layer of OS may not allow it, and it may be a bit of a
Yeah,
hack.
you could already express it through that, so that you have some kind of FCDL, IOCL, whatever. You set on the file to set the new tier and then ask it to apply.
Yeah, I think Alexander's idea was to be able to mark the blocks as dirty, so we never actually have to read the data into user space. It all stays in the kernel. We just flag it as dirty and let
Yeah,
ZFS
that's
rewrite
exactly
it.
why I came up with copy file range as the closest equivalent.
We need some sort of syscall. We don't have good ideas what syscall would it be. Copy file range, could be the closest equivalent, but reading and writing to user space would be no go from the point of locking. From the we must do it within ZFS.
Copy file range doesn't go for user space. It takes an input file descriptor, an offset, and an output file descriptor, an output offset, and a size.
I'm not saying you are wrong. I'm just saying that doing it within, it must be done within ZFS. We cannot even read to kernel right from kernel. It has to stay within ZFS to be safe.
Oh, okay. So it would be a problem if it ends up pulling something into the VFS of a particular operating system to do the copy file range before it dispatches it to the ZFS backend.
Other questions?
Thank you.
This is Brian. This is Miguel. So one thing we worked on today was, with these NVMe devices, they've got block multi-queues backing them up. And currently, we do this interrupt task queue. So you submit an IO, and then an interrupt task queue comes back, and it says, hey, we're done. There's the IO. This obviously could be limiting depending on how many threads you have. So the idea was what if we just issue it and avoid the task queue altogether and actually have a wake up, hey, your IO's done, leverage all the NVMe, queues that are available to us, but unfortunately we just found deadlock so far. So work in progress, but we're hoping to get there. Maybe have less limitations to restrictions on how quickly an IO can complete when you have these queues available to you. Right now we just scoped it to direct IO at the moment too, to kind of make it some more simple at the moment, but yeah.
Question? And how far along are you?
We thought we were getting closer, but then we found more deadlock. Every time we took a step forward, we found more deadlock. So, but yeah, I think we can get there.